In this example, I need to verify the identity cosine squared x over 2 equals sine squared x divided by 2 times the quantity 1 minus cosine x. In verifying identities, we want to start working on the more complicated of the two sides. Initially, that looks like the right-hand side, but on the left-hand side, I have the cosine of the half angle, and here is the formula for the cosine of a over 2, and it looks fairly complicated. So I think I'm going to start working on the left-hand side of the equation. Now remember, cosine squared x over 2, all that means is you take the cosine of x over 2, and then you're going to square it. So I'm going to use this formula over here, but wherever you see an a, we're going to put an x. So I'm going to have plus or minus the square root of 1 plus cosine x, all divided by 2, and then we're going to square that quantity. Well, when I square a positive or square a negative, you get a positive. The square is going to undo this square root, and you're going to get 1 plus cosine x, all divided by 2. I've simplified the left-hand side, but now I'm kind of stuck. There's no obvious next step to make. So when I get stuck, I always look at what are you trying to prove. Do I have anything here that's in what I'm trying to prove? Well, the only thing is I have a 2 in the denominator, and I need that. So looking at what I want 2 times the quantity 1 minus cosine x in the denominator. So I'm going to multiply my denominator by what I want, which is 1 minus cosine x. And if you multiply the denominator by 1 minus cosine x, you have to also multiply the numerator by 1 minus cosine x. And what happens if I do that? Well, in the numerator, I have 2 binomials. I'm going to FOIL them. 1 times 1 is 1. Outer 1 times negative cosine x is negative cosine x. Inner cosine x times 1 is plus cosine x. And cosine x times negative cosine x is negative cosine squared x. All divided by 2 times 1 minus cosine x. I want to leave the denominator alone because that's what I need. Now we can simplify the numerator because negative cosine x plus cosine x add up to 0. So I get 1 minus cosine squared x, which is what you'd expect by multiplying the conjugates 1 plus cosine x times 1 minus cosine x, all divided by 2 times 1 minus cosine x. Looking at the numerator of 1 minus cosine squared x, you should immediately think Pythagorean identities. Sine squared x plus cosine squared x equals 1. So if I subtract cosine squared x from both sides, I get sine squared x equals 1 minus cosine squared x. So now I know my numerator is equal to sine squared x, all divided by my denominator of 2 times 1 minus cosine x. And is that my right-hand side? Yes. And so I have shown the left-hand side equals the right-hand side, so I have verified this identity.